Welcome to part 2 of Getting Started with CNC. Hi, I'm Randy Johnson, and in this session we're going to set up the toolpaths and carve the project that we designed in part 1. At the end of the session, I even go over a simple and quick finishing technique for this project. As a quick review, in part 1 we looked at the overall CNC workflow and focused on creating the drawing for the Gone Fishing sign. In this session, I go over how to create toolpaths and transfer them to the machine for cutting, as well as how to set up the material and calibrate the machine. In the last session, we created the vectors for the project. So now it's time to switch to the toolpath side of the program by simply clicking on the button in the top of the drawing panel. On the toolpath panel, you'll see a group of toolpaths. Each one has a different function, and you can think of it sort of like different machines in your shop. The one on the top left here is called Profile Toolpath, and it acts similar to a bandsaw or a table saw or a handheld router in cutting out a shape. The next one over is called a Pocketing Toolpath, and it creates a mortise similar to mortising or chiseling out a shape. The next one over is the Drilling Toolpath, which acts like a drill press. Down here is the VCarve Toolpath, which is one that we'll be using today. Here we have something for fluting, texturing, special types of lettering, and molding. And at the bottom, we have a couple specifically for 3D carving that we will use in part 3. The first toolpath that we'll set up is the V-carving toolpath. The V-carving will cut the groove, the decorative groove around the edge of the fish, as well as the lettering. The second toolpath we'll use for this project is the Profile Toolpath, which will be used to cut out the project. To access the V-carving toolpath, you click on the icon, which opens the toolpath editing window. And then the first thing you need to do is to make sure and select the vectors of the lines that you wish to carve. In this case, we want to have a border carving around the fish as well as the lettering, and we'll V-carve both of those, and we can select both those groups of lines at this time. One thing that VCarve requires is that the lines you select create an enclosed area, so the V-carving bit can carve inside that area, such as the lettering or this double line around the outside edge. An open design, such as this hook with the opening at the top, VCarve will ignore that, or it'll actually give you an error because it needs to be an enclosed shape like the hook here on the left. Next, we need to select the bit that we'll be using. So we click on Select, which opens the tool database. The tool database is a library of tools, and you can customize it just so it shows the tools that you have in your shop. For this project, I'm going to use a 90-degree half-inch V-bit, and you can see over here where the dimensions for the diameter and the included angle are listed, as well as the number of flutes. And you can set up new bits, you can edit existing bits. It's a very flexible part of the program. The next setting to look at here is called pass depth. And pass depth is how deep the bit will cut every time it takes a pass around your project. In this case, I have it set up to 1/8 of an inch deep. What's important to remember about V cutting and V carving is that the width of your cut, especially for a 90-degree bit, will be twice the depth. So if I'm cutting an 1/8 inch deep, which doesn't seem very aggressive, however, the width is considerably more. So it'll depend on your machine how aggressive you can take this. Larger machines, of course, can be more aggressive than lighter duty machines. The next group of settings for the V-bit is called Final Pass Step Over and Clearance Pass Step Over. Step Over refers to how much the bit steps over each time it takes a new cut. You can think of it much like when you mow your lawn. If you move your lawnmower over half the width of the lawnmower, you've stepped it over 50%. Now for a V-bit, because we're doing the carving with a pointed bit, the step overs are fairly small. The first one I want to look at is called Clearance Pass Step Over. And the Clearance Pass Step Over, as you can see in the picture here, steps the bit over 20% to do the rough carving of a shape. The Final Pass Step Over then comes back and cleans up what's left from the Clearance Pass Step Over to do the final cutting. Your spindle speed, feed rate, and plunge weight will depend a lot on which machine you have. Of course, lighter duty machines, you'll have to be much more conservative in your feed and plunge rate than with a larger machine. We'll take a closer look at that when we get to the profile toolpath setup. For now, we can click on select, which then lists the tool we've selected in the window here. From here, we can accept the rest of the defaults for this particular project, give the toolpath a name, and then click on calculate, which automatically takes us to the 3D window. In the 3D window, what we're looking at here are the blue lines represent where the router bit will be cutting in the wood. The red lines represent where the router bit will be traveling in the air above the material from cut to cut, and the green lines represent the vertical movement of the spindle. You also will see your toolpath listed down here with the name that you gave it. When you click on Preview Selected Toolpath, it then simulates what the actual cutting will look like. It's important to know that what you see here is really what you're going to get. Vectric has done an excellent job of creating this preview, so if anything in this preview doesn't look correct, you should go back to your drawing or back to your toolpath and make the necessary adjustments so that this preview looks the way you want it, because this is what you're going to get on your machine. We're done with this setup, so we can click Close. And now to set up the profile toolpath, we need to go back to the 2D view by clicking on the tab. And then we're going to open up the 2D, or rather the profile toolpath, to access the edit window for the 2D profile toolpath. We're going to select the vector, which is the outermost vector. We need to set a cutting depth. That's a final cutting depth. And in this case, I'm setting it slightly thicker than the material that I'm using because I want to make sure that I'm going to cut all the way through. Same as with the VCarve, I click on select, opens up the database, and in this case, I'm going to use a 1/4 inch end mill. Once again, the diameter is listed, as are the flutes. You also have a pass depth to be concerned about, much like you had with the V-bit, as well as a step over. Now, when you're using a straight bit for the profile toolpath, the profile is simply following a single line around the object. So the step over doesn't apply to profile toolpaths. However, the straight bit can also be used for pocketing when you're pocketing out an area. So in that case, again, going back to the example I used of mowing your lawn, every time this router bit steps over to take a new pass in the width, it'll step over 40%. And if 40% is a pretty as a standard amount, but you can adjust it depending on your kind of work, but it's a good starting point for most setups for the straight bit. Again, the settings down here are going to be dependent on the machine you're using. Your feed rate typically will go much lower than this if you're using a lighter duty desktop machine, and they can even go much higher than this if you're using a full-size industrial machine. One other thing to note is that Vectric has included what's called chip load. Now, chip load is literally the thickness of the chip that's coming off, and it gets a little complex calculating that, so they've included that. But chip load is a result of your feed rate, your spindle speed, as well as the number of flutes, and in some cases it even includes the pass depth. But generally what you're looking for, whatever type of machine you have, you want a chip load such that when you get to your machine, you actually are creating chips, not dust. This can be somewhat challenging on smaller, lighter duty machines, especially those that use a router bit or a woodworking router rather than a spindle. But try to get chips as opposed to dust, or at least get close. On more powerful machines that have spindles and have heavier duty drive motors, it's quite easy to get a nice chip load, as you can see in the picture here. Once again, you click on select, and that tool will be listed in the list. Next up is we want to select the side of the line that we're going to machine on. And of course, for this one, we want to place the router bit to the outside of the line, so we're going to check that box. Next, we want to add a ramp. And you can think of a ramp, as you can see in the picture here, it eases the router bit down into the material. And it's advisable in most setups to always add some amount of ramp. I usually use about 4 times the diameter of the bit, depending on the setup and how deep I'm cutting. But that's a pretty good starting point. You can go more or less with that depending on the material in your setup. Next, I'm going to add what are called tabs. Tabs connect the project to the waste material to keep it from falling out while you're cutting. You have a length and a thickness that you set up, and in this case, it's a 1/2 inch by 1/8 of an inch thick. Again, this will depend on the kind of material you're using and some experience as well. You need to edit tabs and actually add them to the project by clicking on this button. Within this window then, the toolpath tabs edit window, you can simply click on the line. It will add these little yellow tab symbols which signify where the tabs are going to be placed. There's also some automatic settings up here, but usually for a project like this, I just click on it. You want to avoid placing the tabs on inside corners or inside curves, places that it's hard to clean them up, because you will have to go back and carve them off or sand them off. When you have the tab set up, click close to exit that window. The tabs still appear in your main drawing. At this point, we can add a name to this toolpath and click calculate, which brings up a warning, and that's because our job setup originally was set up at 3/4 of an inch thick, but we're actually cutting to a depth slightly deeper than that. Since I'm okay with that, because I intentionally did that, I'm going to say okay. Once again, we're back to the 3D view window. You can see each pass as the router bit travels around for the tool path. The light blue area over here is the ramping, where the router bit is ramping down into the tool. And you can even see down here a little bit where the tab is attached, where the router bit is actually lifting up to leave the tab. Again, we now have 2 tool paths in our list with the one we just added. It is highlighted, which means it is selected. So I can click on this preview selected toolpath, and it'll give us our preview. And there again, you can see the tab that is keeping the project attached to the material. One of the nice features about VCarve, if you want to make a presentation out of this, is you can actually go up and add some color to your toolpaths by clicking on this option at the top here. You can select a color, select the toolpath you want to add it to, and it actually paints it in. Sign makers will often use this to present a preview of what the sign will look like that they can then present to their customers. We're done in this window, so we can click close to exit. Back to our main view. It's now time to save these toolpaths and prepare them for taking them to the machine. So to do that, we'll click on this save icon right here, which opens up the save toolpath icon. We're going to use the selected toolpath option at the top here, and that will refer to whichever toolpath is highlighted down here. That signifies it is selected. And then it also appears in the window here in the middle. So this will be the toolpath that we're going to save out as our first toolpath. Next, you need to select a post-processor, and the post-processor will be specific to your machine. There are a few generic post-processors that apply to systems, but usually you'll have a specific one for your machine. A post-processor acts as a little piece of software to take the information from VCarve for the toolpaths and outputs it as code for the machine to run. Once you've selected the post-processor, you can click on Save. That will then give you an option of where to save it. For this setup, we need to save it to the USB drive because we're going to take that to the machine. Either use the existing name or you can rename it at this point and click Save. Next, we need to go back and do the same thing with the second toolpath. Highlight it to select it. It appears at the top, and click on Save. You can see the previous toolpath now appears on the thumb drive. We can now add the next toolpath by clicking Save. And we can close out of this window. Now, before we leave VCarve, we want to make sure to go back, drop down the file window, and save this file again. Again, this is an important master file. You'll always want to make sure and save it before you exit it, because it's different than the two toolpaths we just saved. In fact, if you go into your computer, you'll see that your VCarve design file, which has a CRV extension to it, is different from G-code toolpaths that we saved to the thumb drive, which have a .tap extension. Now, the extension varies depending on the post-processor you used, but these files are generally referred to as G-code toolpath files, and they are what will actually run the machine, whereas the gone fishing sign over here, that's your master design file. This is by far the most important file, because if you do happen to lose these tap files, you can regenerate them out of the master file. But if you lose the master file, you'll have to recreate it from scratch. So at this point, we're ready to take our thumb drive to the machine. So let's jump over to the machine and set up the machine and cut this project. For this project, I'm using a piece of poplar, which I pre-finished to make it easier to finish later on. I'm applying a piece of tape to the middle of my project, which I'll draw the center data point on the project. Since I've pre-finished this board, I don't want to draw right on the board itself. I'm also using a piece of 1/4 inch MDF underneath the project so that I can cut through it and not worry about cutting into the bed of the machine. I'm also just roughly centering the board on top of the piece of MDF as well as on the machine. Since this project is cut out from the middle of the board and the outside of the board is scrap, I'm not too concerned about having it perfectly aligned with the axes of the machine. Using a couple of shop-made clamps here that both act as hold-ins and hold-downs to keep the board in place. Next up, I'm going to bring the machine forward using the pendant and then raise the Z so I can install the bit. The first bit that I'm going to install is the V-carving bit. When you're installing the bit, it doesn't take a lot of wrench pressure to get it tight. You want it snug, but you don't want it over tight. Next, I'm going to use the pendant to move the V-bit over the datum point so that I can align it with that X. And then using the pendant, I will zero out the X and the Y to the datum point, the same datum point that we set up in VCarve. Next, I'm going to lower the V-bit down closer to the piece of tape and use a Post-it note as a gauge to set up the Z-axis. You'll notice how all three axes on the machine now are zeroed out. Take and raise the bit up a little bit to give myself a little clearance, and then take and pull the tape off since I no longer need that. Next, I'm going to locate the first toolpath file on the thumb drive and launch that file. The router bit then moves down into position and begins the cutting. Once the V-bit carving is done, it's time to switch out and put the straight bit in the end mill. I'm going to move the end mill forward after I've got it installed and zero off the front part of the material. I do not need to re-zero the XY because that's already memorized in the pendant. Once the Z0 is set, I can raise the machine up a bit and bring up the second program and start that running. You notice on the pendant, as the router, or rather the spindle, comes up to speed, there's a countdown of about 10 seconds to give it time to come up to full speed before it starts cutting. Notice also that as it enters the wood for the first time, it does sort of a zigzag. That's the ramping, that it's easing itself down into the material. As it comes back to the starting point again, notice that once again it does that zigzag ramping pattern as it's easing the bit down into the material. It will repeat that zigzag ramping action every time it comes back to the start point for each pass. When the file is done running, the spindle will move over to the start position up to a safe height. So the finished cutout has a little bit of fuzz around the edge, and that's primarily because we were using a up spiral router bit, which tends to pull the grain up. But for this project, that'll sand off easily as we round off the edge with a little bit of sandpaper. On the back side, you clearly see where the tabs are attaching the project to the main material or to the waste material. Next up, I'm going to add a little bit of finish to it. I'm simply going to brush some green paint into that groove and then use a paper towel to rub most of it off. I'm not really too concerned about the amount of paint that's left on the surface because I pre-finished it. When it comes time to sand it off, the sanding goes very quickly, and that's one of the reasons I did the pre-finish. It prevents the green paint from soaking into the grain and leaves a much cleaner finish. It also makes the sanding easier. When that's done, a couple coats of clear finish and the project is complete. Up next is part 3, Introduction to 3D Relief Carving. In that session, we'll look at how to use a 3D model to create a simple relief carving, plus how to add some VCarve details to the curved surface, and the steps involved in machining the project. See you there.